This question is associated with the updates in temporal difference learning, in particular, TD lambda. One way to understand what TD lambda is doing is it's actually a combination of a set of different estimators. And the estimators differ by how many steps of actual reward they use versus when they start doing their bootstrapping based on the value function. So let's consider the process of trying to learn the value for this node here. So TD0 says that we're going to estimate the value of this node by the immediate reward, or the expected immediate reward, plus the expected value of the future. And in this case, what that means is, well, there's 0 reward, immediate reward, and there's 2 different states you could end up in, each with probability of half, and the value function currently says that this one's worth 0 and this one's worth 1. So a one-step estimation, or a TD0 estimation, is 0 plus a half times 0 plus 1. But in the TD setting, this isn't the only kind of estimator we can use. We can also use a two-step estimator. Two-step estimator says we're going to use the actual reward received over 2 consecutive steps, and then we're going to bootstrap. So a two-step estimator for this MDP, starting here, says that while the expected reward of a trajectory going from here down is going to be, well, there's 1 out of 4 ways to get a plus 1. Otherwise, it's all getting zeros. So that's the immediate reward. Just to be clear, we're talking about the gamma equals 1 case. We're not discounting. Then the bootstrapping after that fact is there's equal probability of ending up in either of these 2 states after 2 steps. And so the average of these 2 is going to be the bootstrap value, which stands in for the value of the rest of the run. In this case, the only other step estimator that we can consider is a 3-step estimator that uses 1, 2, 3 steps of real reward, and then it actually reaches the very bottom, and so we don't really need to estimate anything after that. We'll just call that 0. But the 3-step estimator, in this case, gives the actual expected value, which is a quarter plus a quarter times -2. And so these are 3 different ways of trying to estimate what the reward is at this node. Now what TD lambda does is it takes a weighted combination of each of these different estimators, where the weights are defined to be, in this case, 1 minus lambda for the 1-step estimator, 1 minus lambda times lambda for the 2-step estimator, and lambda squared for the 3-step estimator. And in general, it is the form is the k-step estimator gets a weight of 1 minus lambda times lambda raised to the k minus 1. And then in this case where there's a finite sequence, you get lambda to the t for that termination step at t. And so what TD lambda ultimately does is it estimates a value by combining each of the different possible step estimates weighted by these different functions of lambda. And you'll notice if you add these weights together, they sum up to 1. So here's another simple MDP with rewards on the edges written in black, +1, +1, +1, +4, 0 everywhere else. With these probabilities, all the transitions are deterministic except for from this state where it's a half and a half. And these blue numbers represent the initial value function at the different nodes. Each different possible value of lambda here gives a different estimator for the value of the top node. If lambda is 1, the estimator actually returns the true expected value for the sequence of rewards. So for lambda equals 1, the TD lambda estimator is correct, meaning that it actually returns the real expected value. But there is one other, for this example, there is one other value of lambda less than 1 that gives the correct estimator. So what I want you to do is find that value of lambda to 2 digits of accuracy.